Here in example 2, under complex numbers, we have multiplying complex numbers. This first one is just using distributive property. 5 on the outside, you get negative 10. 5 times 3i, you get plus 15i, and that's what we do for that. In example B, we're multiplying two binomials together. And so I'm going to use distributive property or FOIL. 2 times 4 is 8. 2 times 3i is plus 6i. Negative 4 times I is negative 4i. Negative I times 3i is negative 3i squared. And if you recall from Algebra 2, I squared is equal to negative 1. Therefore, negative 3i squared would be negative 3 times negative 1, or positive 3. So when I go to simplify this, it would be 8 plus 3, where that 3 comes from over here, that plus 3. And then I minus 4i. 8 plus 3 is 11. I minus 4i is negative 3i, and the answer is 11 minus 3i. Okay? The next part, part C, again, two complex numbers. If you recall from Algebra 2, when I have 3 plus 2i and 3 minus 2i, these are known as complex conjugates. And what was special about complex conjugate is that when I multiply those two together, the imaginary part drops out and you're left with only a real number. So let's see how that works. 3 times 3 is 9. 3 times negative 2 is negative 6i. 2 times 3i is 6i. And 2i times 2i is negative 4i squared. Again, recall that negative 4i squared is the same as negative 4 times negative 1, because I squared was negative 1. Negative 4 times negative 1 is 4. So this would be 9. The negative 4i squared would be plus 4. These two are opposites, they cancel out, and I'm left with 13. So again, the idea of complex conjugates means that when I multiply the two binomials together, the imaginary part drops out and it leaves only a whole number of 13. Notice that the numbers are exactly the same, 3 and 3, 2i and 2i. The only difference is positive 2i in the first, negative 2i in the second. That's the difference for complex conjugates. Alright, moving on to part D of this example. If I have 4i times negative 1 plus 5i, 4i times negative 1 is negative 4i. 4i times 5i is positive 20i squared. And again, from up here, I squared is negative 1. Therefore, when I get I squared, I have to take it 20 times negative 1, which is negative 20. So this would become negative 4i minus 20. Then to write it in standard form, I need to write the real part first. So it's negative 20 minus 4i. One last example here. Example E is going to be 3 plus 2i quantity squared. One way to do it is to go 3 plus 2i times 3 plus 2i, multiply that to get the right answer. That'll work. What I'd like to see you do is say, okay, square the first term 9. 3 times 2 is 6. 6 times 2 is 12, so it's plus 12i. 2i squared would be 4i squared. If you remember, this would be 2i quantity squared. 2i squared is 4i squared. Remember that 2i squared is the same thing as negative 4 because it's 4 times negative 1. And then 9 minus 4 is 5, and you get plus 12i. If you have trouble following the pattern that I did here for the 3 plus 2i squared, go ahead and work it out with 3 plus 2i times 3 plus 2i. You'll get the same answer as long as you do your math correctly.